Okay, so today we're going to be looking at interference of wave. Well, there are a few terms that you need to know because these are going to be new for you. So some of the terms will be the principle of superposition, coherent source, and constructive and destructive interference. Okay, so the first thing first, let's look at the definition for interference. So this here is the definition for interference. It's the superposition of two coherent sources, and it happens to produce constructive interference or destructive interference. So that's why you also need to know what is constructive, destructive, superposition, and also coherent, because it is there inside of the definition of the interference itself. Okay, so now we're going to be looking at the definition for coherent source. So coherent source means the same wave, basically. So it's wave with the same frequency, same wavelength, same amplitude, and same phase differences. All right, now for the principle of superposition. Okay, this one you have to memorize because this is very popular in SPM, so it's always asked. Okay, so the definition for the principle of superposition is that when two waves meet, so the displacement of these two waves, or the resultant displacement of these two waves, is become like the total displacement of the both of that individual wave. But you'll see when I show you the animation later on. All right, so this animation here, the first one, this is constructive interference. So here is the amplitude of the first two waves that comes in. And when they meet at the center, it will become double because they are added together. And then for destructive interference, these are their amplitude in the beginning. And then when they meet at the center, it will cancel out each other. Okay, so from the animation, you can see that there are two instances that happens when a superposition happens. The first one is that it produces a larger wave, and the second one is that it cancels out each other. Okay, so when it produces a larger wave, either a larger crest or a larger trough, then that means we call it a constructive interference. But when it cancels out each other and it becomes flat like that, so that is the destructive interference. Okay. Okay, so now we're going to be looking at the pattern. So interference of water wave. An example is here. So you can see that there are areas here where the crest, is become more or double the amplitude than previous. And there are area where there is none. Okay, so the area where there's none, then there's no waves, then that is the destructive interference. And the area where the waves become higher up or higher down, that is the constructive interference. Okay, to see in details is over here. So if this is a crest and this dotted line is a trough, then you have to check out the area here to find the constructive interference and where is the destructive interference. So we can see this further in a colored drawing. Okay, so let's say that this is the water waves just now, with the dark blue being the crest and the dotted lines, light blue being the trough. So I'm going to use the yellow color to show you the constructive interference. So constructive happens when a trough meets a trough or a crest meets a crest. So like over here, this is crest meet a crest. So that is constructive. Trough meet a trough, constructive, 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 and so on, right? So another part where they are constructive, same type of wave, same type of phase, which is either they are crest or trough, then they will produce a constructive. So now destructive, I'm going to use black for this. So destructive is when a crest meet a trough. For example, here. Okay, you got that light blue and dark blue. So out of all these points later on, when you connect them together, then you will be able to see a lines that is made up of constructive interference and lines that are made up of destructive interference. Okay, so let's draw them. All right, roughly. So these destructive lines, we call it the nodal lines. Okay, and then let's try and draw the lines for the constructive interference. Okay, roughly. Okay, and for lines that made up of constructive interference, we call it the anti-nodal lines. Okay, so now let's take a look at the interference of light. So you make a single slit first because you want to produce a coherent source. When it is coherent, meaning that it is light of the same wavelength that comes out here, then you make the slit become two slit. Then you produce two source of wave that's coming out. So now you've got interference pattern over here. So where the lines that is made up of just constructive, okay, then it will create a bright fringe, and those destructive will make a dark fringe, bright, dark, and bright. Okay. That in the end, if you look at it, then it will look like fringes like this. So for interference of light, there is a formula that you need to know for SPM syllabus. It's lambda equals to AX over D. So lambda is of course the wavelength of the light here. You need to know what is A, what is X, and what is D, because that is the thing where students often get confused with, right? So lambda is the wavelength. A is the distance between the two slits. So if it's here and here, so the distance between that two slit separation just now, we call that is the A. And D, just remember that is the capital, so it's the distance from where you have that slit of yours to the screen where you project the diffraction pattern. And usually it will be up until 1 meter, more than 1 meter. So let's say if you don't remember this kind of thing, and then you see like one of the value in the question is like 1 meter or 0.2 meter or 100 centimeter. So then that definitely will be the D. Okay. And then X is the distance from one bright, the center of one bright to the center of the other bright, or the dark to the dark. Okay, so that will be the X. Okay, interference of sound is caused by, you need to also make sure that the sound wave that you get for here is a coherent sound. So, you know, like some speaker, they got two speakers over there, right? So that will be the coherent source. And then when you put them closer together or far away, then you'll be able to observe whether this sound interfere each other or not. Like in this case here, you can see that this red here is the constructive interference, okay? And the blue is the destructive interference. So if you draw the nodal and anti-nodal lines, then you'll be able to determine where is the loud sound and where is the soft sound, okay? So then loud, soft, loud, like that. So if someone was to walk through here as that sound is being projected, then as he or she walk, then he or she will be able to hear a loud, soft sound, loud, soft sound, loud, soft sound, yeah, alternately, all right? So in an experiment setting, this is how it looks like. You got that audio signal generator connected to two speakers that is set to be a few distance apart. And then the students have to walk through and mark the area where you hear the loud sound and the soft sound. Okay. So now let's look at the sample SPM question. So let's look at for superposition first. Okay, first question here. Okay, so you can have a look at the question, pause the video, try it out, and then come back later for the answer. Okay, so first question is asking you the principle of superposition. Okay, so like I told you, is a very popular question in SPM. So we just write down the principle of superposition. And second question, they ask you to complete for diagram 4. Okay, so this is two crests coming to meet each other at the center. So crest and crest will produce a constructive interference. So then at where the cork is, the waves will become bigger and the cork will be here, and the amplitude will become double, which is A plus A, so 2A, right? And then the types of interference that occurs is constructive interference. Okay, what happened to the motion of the cork? Lifted up to an amplitude of 2A. So this one we'll have to use a formula for it. Separation between dippers, then that will be our A. And then the separation between two consecutive antinodes is our X. You just have to make sure that in the end they are all the same unit. But in this case here, all cm, you can just write it all in cm actually. So if you work that out, then you should get 1.2 cm. Okay, so separation between two sources increase to 9 cm. Okay, so if you look at the formula, and they want to know now the relationship between A and the relationship between X. So A increase, what happened to X? Okay, is it increase or is it decrease? So you kind of have to derive their relationship from here. So they need to be on the opposite side of the equal sign. So if this is increased because it's the numerator and this is the denominator, then it will be inversely proportional. So if A increase, then X will decrease. You really need to brush up your maths on that. Okay, second question, in the diagram, we need to label the nodes and antinodes. Okay, so that's just, you can try out the question and come back later for the answer. Okay, so remember that nodes is destructive and antinodes is constructive. So over here, we are trying to find the nodes now, which is the constructive. So it will be this, 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 and this. Sorry, constructive will be the antinodes. So these are all the constructive now, the constructive points. Yeah, okay. And then the nodes will be the destructive. So there will be this, this, and this. Okay, QRV. Yeah, that's it. Okay, another practice question. You can pause the video and try this out. Okay, so this question is using the formula again, which is lambda equals to AX over D. Okay, and what you're trying to find here, okay, what is given to you here is D, and then separation between two slits, this will be A, and you need to find X. Okay, and wavelength is given here. All right, so let's rearrange this formula to be X. So it's easier for us to do it. Okay, for A. Okay, for this question, you need to make sure that you convert everything to standard units so that all of them will be in the same unit when you calculate them. So for violet light, so the wavelength is 4 times 10 to the power negative 7. D is 4. And A is 0.5 times 10 to the power negative 3. Okay, and for red light, only the wavelength is different. Okay, so if you work out, then you will get 3.2 times 10 to the power negative 3 meter. You can also write it as 3.2 millimeter. And here you will get 5.6 times 10 to the power negative 3 meter. And 6 millimeter. Okay. Last question. You can read out the question, try it, pause the video, and come back later for the answer. Okay, so this experiment is just like the one that I showed you before, the experiment about sound interference. So the question here, they gave you the distance of A, which is the distance between the two speakers. And then they also give you the frequency, right? And here's the question. Okay, what type of sound can be heard? So the sound that the student can hear, or the sound that is captured by the microphone in this case, will be an alternate of loud and soft sound, which is the interference. Okay. And then for B, you need to describe how you get that loud sound and how you get that soft sound. And then if the frequency is increased, what difference can be observed? So for this, you need to know the relationship between frequency and also wavelength, because in the formula that we have, which is this, there is no frequency. So the only way you can relate how frequency changes can affect is wavelength, because you also know that V is equals to F lambda. So if F increase here, and lambda is inversely proportional to F, so wavelength will decrease. Okay, so if wavelength decrease, what will happen to A? No, what you observe is X, right? So what will happen to X? Then X will decrease too, because they are both numerator, so they are directly proportional to each other. So then that means that if you increase the frequency, then this L and S will be like closer together like this. Okay, so in words you can write you can write about X, or okay, you can also talk about the kind of sound that you hear. So the loud sound become closer together for the interference pattern, or as you move the microphone, then you can hear the loud and soft sound at a faster rate. Okay, so last question is to calculate the wavelength, and they give you the speed, and the frequency is also given at the top, which is 600. Everything is already in standard unit, so you can just apply the formula. You will get 0.5 meter. Okay, so as a summary, what we've learned today, we've learned the definition for principle of superposition. We've learned a few other definitions as well. Interference, which is two, constructive and destructive, coherent. Okay. And then you've looked at the patterns of interference for all three types of waves, which is water, sound, and light. And then we've done some calculations as well using lambda equals to AX over D. Okay, so that's all for today's video. Thank you for watching.